All right. So under this unit of software engineering methods, we looked around a lot of theory aspects. And in the last few weeks, we also looked at practical aspects, right? So I've selected the Laravel, a PHP framework, to try out the theory that we are learning here. We looked at how we can manage our code repositories and then use that also in order to get an entire project management done when it comes to software development. For that, we use Jira. And then we also wrote a small program with minimum changes with the Laravel system. And before we go to the next level, I thought maybe we spend some time looking at the options available when it comes to software architecture. We use this word called pattern in many places. We use pattern for software application patterns, software architecture patterns, and various component patterns and things like that. So today we are going to look at the architecture patterns, and then we will see out of these patterns, what are the patterns we see inside Laravel. Okay, there are few, more than one patterns we can identify there. And also, if you look at the software development patterns, also there are so many things that we can immediately see in the Laravel platform. Especially, I mean, you can see them in any object-oriented application system like factory, strategy, and then various things of that nature. We can identify them as well within our Laravel system. So learning theory is one thing, but understanding where the theory is actually used is another thing. So the best way to understand any theory is to use it in a problem area and then try to understand, okay, what is the role of this theory here? Okay. So let's look at some of the architectural patterns available and then where we can use each one, what are the advantages and also what are the disadvantages. So in general, we use the word pattern as a term for reusable solutions, right? What does that mean? Now, these are patterns identified and developed by highly experienced people who've been developing software for a long time. And when you develop software for a long time, you will notice some repetitions, same thing happening again and again and again, right? So then you can maybe customize that or maybe fine tune it, and then you can call it a pattern. For example, user registration pattern, right? Which is very common for any software. Or user password request pattern, again, very common for any software. So likewise, now those are actually application features. But then if you look at the entire software system, the architecture, even that can be also identified as patterns because there are different patterns available to build our software. Okay, so these patterns help architects design software systems by providing proven solution and best practices. What does that mean? If you are not sure about how to architect a piece of software, you can look at the patterns already available and then choose, okay, which one is most suitable for my application. For example, if your application requires a real-time chat system, okay, or if your system is like a event-driven area where like Uber kind of application, where the clients are continuously pushing information to a server. A server needs to keep on receiving and then processing and send it back and stuff like that. Or you have a UI-based application where you are listening to UI events, and then based on the event from the user, you do some action, you go to the database, update it, and come back, and stuff like that. So these are patterns. Okay, so these are different patterns, and when we learned about the patterns, we will be able to understand, okay, which pattern is suitable where. So to start with, I'm going to go with the most simple and also very famous pattern called the MVC pattern. MVC stands for Model View Controller. In fact, Laravel is a very good example when it comes to MVC application. So under MVC, we break down the system into three main layers: model layer, controller layer, and the view layer. Right? Very, very common among e-commerce sites and web-based applications. Even for mobile-based applications, this is very common. So what are some of the benefits? Separation of concern. That means each layer will be doing one job. That's it. So if something is to be changed, you can change that layer. Now, for example, your view layer can be developed using HTML, CSS, JavaScript, and something like that. Or you can use your view layer developed with Flutter, which can be then running on either a browser or your mobile phone, right? Or in Laravel's case, Laravel uses something called Blade, a Blade engine for view templating. So then what is coming out from the Blade engine is HTML. So you can watch it from your mobile phone browser or from your laptop browser. So it's a browser-based application, right? What are some of the issues or trade-offs? Can lead to performance overhead, meaning if your database is slowing things down, your entire application will feel like it's slow, right? Or if your controller is not having enough memory to run, or it doesn't use cache memory, then you will feel like the whole system is slow as well. And since there's just 3 layers, of course, there are so many other ways where you can extend it. So we start with MVC, but then we can bring in other layers. So we can have integrations, we can have APIs, we can even run it, some of the component as an API engine, stuff like that. But as a simple MVC application, scalability might be an issue if it works within the system, right? So for example, if you take Laravel, it's okay for small scale application because of the Blade engine. But if you are looking at like a very complex application, there may be other solutions you can look into as well. You can go with Laravel, of course, but then that also requires optimizing your server, right? And also throwing in a lot of memory or RAM and let the database run within RAM than from the disk. So there are a lot of optimization we can do, but that's not for the normal applications. So the examples are pretty much any web-based application where the user interface is the main thing and it is separated from business logic and the data storage. So if you look at a diagram, how MVC works. So here we are, the user, okay? So user sees a view. So I go to a web browser, I see some buttons and various things. And then I click on something. So I'm creating an event now. I'm using the view, right? And then that action goes to a control. So when I press a button, that button press goes to a control. And then controller either, maybe save something or update something, or basically it is manipulating the model, or the model is the database. And this manipulated database is now updating the view, right? So actually, in a way, this is not correct also because model cannot talk to view directly. Generally, it is the controller that is actually updating the view. So this is a much better a diagram. But the first one is, simplified version. So here's the user. User is interacting with the view. So the UI events are going to the controller. And then controller either can talk to the model, which is the local memory. It can also connect things from others through APIs. And then it send it back to the view to update. See, the model will never speak to the view directly. So this is a better example. But this is a simple example to understand how MVC works. Our next pattern is called a layered pattern or entire pattern. Actually, MVC is also coming under the layered pattern, but I took it separately because it's a interesting one we should look into. So different layers are there. Just like MVC, there are presentation layers, business logic layers, data access layers, and then there are databases, stuff like that, right? So this is actually very similar to what we're talking about on the MVC. MVC is one of the entire application examples. So the biggest advantage here is you can replace any layer you want, right? So for example, say you want to replace the database from MySQL to Oracle, no problem. You can do that without changing your business logic or the UI. Similarly, you want to change the UI from HTML to Flutter, no problem. Nothing else will change, only the UI will change. Okay. So here are some simplified diagrams. So one on the right hand side, this is the Windows desktop application mechanism, right? So there are various layers here. Next one is called client server pattern. Now, what does that mean? In this one, we have two layers. We have client and then we have the server, right? Very famous in the early days of networking. Like say, for example, in a bank has a massive server sitting in their head office, and all the branch offices are using something called the dumb terminal to connect to the server. So the branch office is not doing any processing in their computer. They are only entering the data to the terminal, and the terminal is sending it to the server. Server is processing the information and send it back to the terminal. So that's why we call it the client server system. If you want to change something in the server, you just change it in one location because it is centralized managed. And if you want to add more clients, no problem. You can start adding more terminals to the system. But having said that, there can be also server bottlenecks. Now, although we see this as a very ancient system, but if you look at the current web-based application system, this is exactly what we're using even now, isn't it? Client server pattern. So if you take a web server, the web server has a finite amount of memory, hard disk capacity, CPU time, and network speed and all that stuff. So when you start adding more clients and more clients and more clients, there will be a time where the server cannot handle the load, right? So network is also issue there. You might have a fantastic high-speed server, but if your network is slow, then we will also have serious issues there. Very good example is during COVID-19 time, 2021, I believe. No, 2020 and 21, both. Most of the, actually, three supermarket famous in Sri Lanka, who's also famous for online ordering, right? Keel Super, Cargill's, and Apico, all three crashed. That is because of the bottlenecks, right? So, I mean, they didn't expect a lot of people coming to order things online at the same time, and they did, and we had a serious breakdown even there. Here's a diagram showing us how a client server is working, right? So there is one big server and all the others are clients. Now, you notice the client is also a computer, right? Although sometimes we call them dumb terminal, they can be computers as well. Like at the bank, they are using desktop computers to connect to their server, which is not at that branch. It may be in the head office, or maybe not even at the head office, maybe somewhere else in a server hosting environment. Here is a complete diagram of a client server, right? So one in the left is a very simple one. On the right, you can see the actual scenario. So we have something called the content delivery network or CDNs now. We also have a separate cache servers caching the content on RAM. And then we also have something called the load balancer, because if you have more content, or actually more users coming in, then your servers can handle. The load balancer will manage using multiple servers, right? So the mechanism is now pretty complex than earlier. We are talking about millions of users at the same time, right? So in that case, we need to also do the architecture to support that as well. Next one is also very famous, microservices pattern. Now, what does that mean? Here, we take a big program or big application and we break it down into separate servers running on different port numbers. Okay. And that way you can in fact assign them in, you can run all the microservices in one computer physically, or multiple physical computers also can be used. And they don't have to be in the same place as well. So if you know the IP address and the port number, you can connect to that server and then get the job done, right? So one of the biggest advantage here is scalability. You can start with 10, then you can increase it to 1,000, 10,000, 10 million, 1 billion, whatever. So it's very easy to, there are lots of different architectures available for microservices. For example, Node, right? Node is a JavaScript based server where it can very efficiently handle API request. So we can have multiple Node servers running and managing multiple different services. So your one application, client application, can be talking to multiple microservices to get various things done, right? So benefit is obviously scalability, and also the fact that they are separately developed. You can also do the deployment separately as well. And there are so many technologies out there, including Laravel. We will be looking at that. There is JavaScript. There are so many other languages that we can use to get these microservices running. So what are some of the trade-offs? Complexity in managing multiple services, right? So if you are writing microservices, you may be, well, if you are the project manager, you can then assign different people for different services. But then if the same person is handling different services, then we might have issues there, unless they are really good experts, right? Now, since they are running on their own network, own servers, own computers, network overhead is a serious issue. Because say you might have a authentication server running, and authentication can happen very quickly. And then after the authentication, you want to connect to somewhere else, download the catalog or something, then you will have serious issues there due to the network overhead. And then also data consistency challenge. Now, of course, we solve this by having somebody in the middle, a middle layer. But then if you are duplicating data from one server to another server, you got to be very careful, because the format might change anytime of the original computer. The last point says large scale applications like e-commerce platforms where different services handle user management, inventory payment, etc. So if you look at an example, right? So we have a browser-based application and also app-based application. All of them are talking to the same API gateway. And through that, we can speak to different components. So the first one is Angular UI. Second is inventory service. Third is shipping service. And then we have account service. So account service is directly connected to the database. Here, shipping service is connected to something else. Inventory service connected to something else. So the diagram on the right-hand side is another way to look at this as well. So in fact, although we don't advertise it, but there can be some sort of a API database, right, where you can go and subscribe yourself. So if you notice in this example, the browser is connecting to storefront web application and then get account services from this box, and inventory services from this box, and shipping services from this box. Right. Our next one is event-driven pattern. Now, what does that mean? Now, if you look at the screen here, there are buttons and various things which I can click, isn't it? So by doing so, what I'm doing here is actually I am creating an event. Like pressing a button is event creation, right? Of course, there are a couple of things happening here. One is the component creating the event. It's called the event source. And then on the other side, we have the event observer, right? Or a subscriber, we call it. So someone taking the event or listening to the event and doing some work. And there can be also a message queue, meaning like imagine if 100 people create the same message, or sorry, same event. How do you handle this? So you need to very accurately put them into something called the message queue, and then take one at the end, one at a time. So what are some of the benefits? Highly decoupled systems. Decouple means they're not together, they're separated, right? Scalability and flexibility. That is also very important. You can scale and scale. So if you want more subscribers, fine. More computers can be added. And also another biggest advantage here is this is asynchronous communication, meaning opposite of this is synchronous communication. Under synchronous communication, you have to send a message and wait until they accept it, right? Whereas asynchronous, you don't need to. You can send your stuff and then go do something else. And when the recipient ready, they will send you a message saying, okay, we are ready now. So that's the difference between asynchronous and synchronous communication. So what are some of the issues under event-driven pattern? Complexity in managing events and eventual consistency, debugging, and monitoring challenges. So eventful consistency, what does that mean? So when you have an event, you are not part of the session. If you know what the session is, right? When an event happens, you are getting a request from somewhere and you may not be part of the session. So you need to come up with a mechanism to identify what session are we talking about, right? So that's why I said it adds a little bit of extra work, but it is fully worth it. And also having said that, now when it comes to debugging and monitoring, it's pretty challenging to handle event because event can happen anytime. Sometimes you can't stop it also. So how do you make it work, right? So this can be a white box testing when it comes to testing, because you need to have access to the source code also. And then where can we use it? This is very famous among chat applications and also monitoring system, dashboards, and also IoT applications. Here's an example. On the left, we have the producer application creating an event. On the right, we have consumers, someone who's using the event that is generated by the producer, right? But then we also need somebody in between, connecting them together. So we call them the event broker. There is some sort of a subscription mechanism is required. So the consumer need to subscribe to the event, and we do it through the broker. If you look at a better example, yeah, here's a better example. So let's say you go to an e-commerce site and you cancel an order, right? When you cancel an order, there are different things we need to do to different services, right? So number one is sending an email. Number two, initiate refunding. Number three, clean up order data. Number four, notify the admin. So these are four different things we need to do. And we need some sort of a subscription by others so that they will get this message. For example, there's a listener one listening for email sending business. There's a listener two who's looking for initiate refunding activities. There's a listener three looking at cleaning up the database. And then listener four is looking at whenever someone have an order cancellation, they will inform the admin about, okay, there is a problem with our ordering system. Next comes So microkernel plugin. Actually, when you say microkernel, we generally think about either a CPU or an operating system. But you can also use it for your application development as well, right? So the advantage here is you have separate plugins that gets plugged into the main system, right? And which means, I mean, there are a lot of benefits. You can keep adding new features to your system. And it also simplifies update and maintenance, because if you know some component is not functioning, you can bring it down without bringing down the entire system, and then fix it back, and then you can plug it again. All right. So a perfect example is IDEs. It might be Visual Studio, it might be anything for that matter. If you look at them, pretty much all the latest IDEs have expansion capability, where you can download and add an extended plugin, right? So that's a perfect example. So here we go. If you look at the left-hand side, we have market data coming up, and then the market plugin will process that, right? And then there is also market history, basically reading the market plugin and getting the information from the database and then giving it to the microkernel. So microkernel will decide, okay, who should need, say, for example, strategy. Who wants notification? Who wants trading? Who wants, various other services as well. Next one, is also a very famous among large-scale application. This is called SOA, Service-Oriented Architecture, right? Very famous among large-scale application. So what we do here is we design the whole system as a collection of services, right? And what's more, these services are self-contained, right? So they can run on their own without talking to any other module. So since they are running independently, we can very well reuse these services, right? Well, sounds like a very good plan, but it also has few trade-offs. For example, performance overhead, right? So how do you know whether the other party is processing information faster, right? So that's another important there. Look at the example, enterprise application that integrate various services like payment, processing, inventory. Yes. So for example, you want to set up a WordPress site and you want to bring in the commercial bank credit card system. Well, then you need a plugin, commercial bank credit card plugin. You just download, install it. Voila, you have it, right? So that's the beauty of object-oriented architecture. Here's another way to look at it, right? So we have a client. ESB stands for Enterprise Service Bus. It's like a highway where all the clients are requesting information, and the ESB will pass it on to the relevant parts and receive the same information back to the client. So we have the service-oriented architecture, or service bus, it's called Enterprise Service Bus. And within that box, you notice we have the entire SOA system. So we have a CRM, order management, billing, and they're all going into one big shared database where we might be taking a backup of all that every now and then. Here's another way to look at it. There is a service provider, then there is a service registry, and then there is service consumer. So consumer want to find out who has this information, right? So the consumer will go to the service registry, and there he or she will be able to find related things there. And then you start the conversation. Next up is pipe and filter pattern. What does that mean? Pipe and filter. So something coming out of one pipe, you are taking into the next pipe input, right? So let's see how it's done. This can't be. Presentation. Okay, so our next pattern is broker pattern. I think we looked at the event-driven architecture. There is also a broker there, right? So, well, very similar. It's just that we keep this very simple. So if you look at the diagram, right? Oops. So there is the broker. Broker is getting the messages from various service publishers, and then it try to understand, which subscriber might have a least amount of time by talking to multiple servers and getting the topic. And then you can start, once you're locked in, you can start communicating with the person. All right. Master slave pattern is another one. By the way, now, although we call it master slave, there's a certain movement going on, especially in US when it comes to slavery. So much so, they propose not to use the word master in our branching, Git branching. So they want us to use the word main, okay, just to sort of respect the Black people. So master slave might be renamed again later, so keep that in mind. So here again, the master controls more than one component. And the slaves can't do anything on their own. They will only do what the master asks them to do, right? So the issues are reliability when it comes to especially the database replication. So there is one database handling all the slaves at the same time. So you got to try it out and see how it is. Here's an example. So there is a master and then these are clients. Next up is a very famous pattern, peer-to-peer pattern. If you noticed, if you learned about, say, torrents, this is how it works, right? So peer-to-peer is directly connecting to one other computer on the network and then have direct communication. So you got to be careful about to whom you are opening it up, right? And the benefits, it says, or example, it says file sharing network is like BitTorrent torrent and blockchain. So, well, I would say yes and no, depending on how do you want to manage it. So if it is like a livestock that you want to manage with peer-to-peer pattern, yes, you can. Now, what about this one here? Let me show an example here. So if you look at the right-hand side, we have all the clients connected to all the client, isn't it? All the clients connected to all the clients. So, which means anyone can talk to anyone on the network directly rather than going through a server, like in the left-hand side, right? So that is peer-to-peer power. Which brings us to, okay, so that's all the theories. Now, how can we see this theory in practice? Like I said in the beginning, Laravel can be used as an MVC example, and also can be used as a microservice example, and also can be used as an event subscription example. Let's switch to VS Code. All right. So from last week's code, I showed you the code repo is available on Bitbucket. So this is our repo. So there are setup instructions. So you can clone this and then go through these instructions to get your code up and running. So you have to compose install, npm install. So we are installing the PHP stuff with this, and JavaScript and CSS with this. Okay. And then we need to generate a key, migrate our database, and then we run two servers, one to manage the JavaScript and CSS, and also another one to run our web server. This is to map our storage. That is, like when you're uploading something, it saves into a certain folder. So once everything is done, you can either go to this URL or this URL to get your server running. And these are the credentials, login credentials. And I also use few third-party libraries. I'll show you today what is being done there. Also, like I said, if you are careful, you will be able to see multiple branches in the source code as well. So I have a master branch, and then I have a dev branch as well. And then there is, if you remember, the book factory is what we did last week. And dev branch actually is a bit ahead of the other branches. So I added a few things there. So I've also added something called the CSV seeder. I'm also adding API documentation and stuff like that so that we can improve our code base. Yeah. So, but then my advice to you is start with the master branch and see how things work. So if you look at the output, there is, yeah, here's where our code is running, right? So you can go to login and test example, and password is the password, and then log. Oh, by the way, I added a login with Google. This I did for another unit, social media technique unit. So I'm using the same code base, but there is a new branch for that, right? Google login branch. So I'll probably have that branch taking care of the social login there. Okay, so here's our project after logging in. So I have two entities. One is books, the other one is authors. If you go to books, I also did some work here. So now here's the book list. By the way, this data is created using something called the factory pattern. That's why I said we are using some patterns here in order to understand our theory. Now, what I'm doing right now is I'm using the MVC architecture, MVC pattern. So this is my UI, and these are the buttons which I can use to give action. So for example, if I want to delete this, I can click the delete button. I have a pop-up here. So this is coming from the third-party library I was talking about, SweetAlert, right? So these are links, by the way. You can go and learn about it if you want to. And if you say delete it, it will be deleted. And then there is a message here saying it is deleted. And then if you want to view something, you can click the view button. Now see, when I click the view button, so I am going to the action, right? So going back to our presentation, our first pattern. This one. So when I clicked on the button, when I clicked on the button, it goes to the controller and then to the model and then comes back with the information. So how does it actually work in the code? Right. So this is something that we saw on the code. So this is the view of the CRUD. And I can click the edit button in case if I want to change this. And then I can, change something and press the submit button, or I can clear the whole thing. I don't think the code is running here. Let me show you the code now. Okay. So let me close everything. Let's go back to the view. So I have a folder here, by the way, for books and authors. So let's take the books folder because that is the available code. So I have one called the indexblade.php. This is the view file. Now you notice this is HTML, right? It is using an HTML table. I have a title, ISBN, actions. These are the main row, which is this is the index file. So title, ISBN, publish, and action. So and then I have a for each loop, right? I have a for each loop for every book. It's going through basically showing everyone there. And the for each loop ends here, end for each. And within this for each loop, I am actually processing books, all the books from my collection, and I'm taking it one book at a time, and I'm processing one book at a time. So I'm taking the book title, book published at, book ISBN, and then I have two buttons, one for view, one for delete, right? So where is this books coming from? I'm in view. Okay, that is coming from my controller, which is here, book control. In fact, I'm using the index route or index method here. So this is how I'm getting the entire data set. So book is my model, right? Which is here. And when I do this, when I say book all, I'm getting a collection, which I'm storing in books variable. And then I'm passing that to my view, books.index. I'm passing that as a books collection. Now this line number 31 is required for that pop-up, by the way. Okay, so, and then when I click the view button, it comes to this one, the show method, right? So I'm getting a book. I'm just passing that one book to the books view method, or books view, by the way, the view blade file, we call it, right? And edit goes here as well. If you look at the delete button, there is a destroy method, which is basically destroying. So book delete is the method I'm calling. Toast is that little message on the top right hand corner you saw. And then after deleting, I'm redirecting back to my index method, which is here. I delete one book, I go back to the list again, this one. And this is a little bit of documentation I'm using here. So I'm using REST method in my route. So if you want the entire list, you just do a get method and you will get everything, right? And if you want to look at just one, you will need just the name of that, actually the ID of that one object, and then it will be read to you. So we also saw models, right? So here's the book model. Nothing much to do here with Laravel, but I'm using some advanced filters here. So these are called fillables, right? These are called mass assignable, meaning you can prevent hacking using these things, right? You can prevent unauthorized access. So filling the table or accessing password, stuff like that. And that's what I'm doing. I'm also transforming some of the filters. I mean, fields like say publish that is a custom field. I'm transforming it to a Laravel date collection so that I can process it properly. I'm also using something called enumerators. You don't need to use any of this, right? These are a bit advanced stuff. This code is available in the dev branch. Okay, here, the dev branch. And you can always jump back to master. And master branch is very simple. So if you want simple output, go with the master branch. If you need to understand this further, go with the dev branch or the development branch. So these are the rules I'm using. And I'm also using something called the pivot table. So that I can, okay, one book can be written by multiple authors, and then one author may have written multiple books, right? So many to many. So I'm using something called pivot table for that. So if you look at the database folder, under that you have factories. Factory, I have one for the book. So it's essentially, filling the information. So these are the fields I'm filling in with Faker. Faker is, randomly generated data. And under the migration, I have the information about the book table, like, what is the type of the field, and then are there any default values and stuff like that. So user ID is the person who created the book. So if it is not mentioned, I'm adding number one, which is our default person. So published at, and also status, I told you, I'm using enumerator field. So author is very similar. And then I have another special table called author and book. Here I only have two fields, author ID and the book ID. That's all. This is the pivot table, by the way. And also, I'm using another method or another pattern called the seeder pattern, where I am actually I'm using two ways. So I am manually adding a user, right? Using the user factory pattern, I'm using this to add one user called test user, and this is the testexample.com. And if you notice very carefully, there is also user factory here. So if you don't give a password, automatically the word password is added to the user. So that is what is happening here. I'm not giving a password, it's automatically creating the default password. And I'm calling author table seeder and the book table seeder. And then I'm also mapping out the pivot table using some random number between 1 and 10 and 1 and 20. Because I'm adding, if you look at book table seeder, I'm adding, using the factory, I'm adding 20 books. Very simple to add 20 books. I don't need to type anything. Similarly, for my author, I'm using a nice technique where I'm reading a CSV file, which is here. So I'm reading this CSV file directly to the database using the author table seeder. But here, I'm using the factory method to generate records. And here I am manually generating one record. So if you look at the database from here, right? So this is my database. This one, right? So these are the books, right? Randomly generated 20 books. This is 11 authors I read from the CSV file. And this is the user I generated from my code. You notice the password is encrypted. There is also something called the remember token, which is that little tick box on the login screen to say, remember me. And these two fields are automatically added from Laravel, created and updated. Yeah. Okay. So the other tables are there for various activities like the cache, failed jobs, migration, password, and all that stuff, sessions also. So the tables I added are author book, and then users. The rest is coming from Laravel. Right? So this is what is happening with the code. So I strongly recommend you to go through this code, study the master branch, which is a simple example. So next time, now here we build a MVC, right? So we have the view, we have the controller, and then we have the model. So next time, I'm going to show you how we can use the same system as an API backend, right? So for that, I'll probably use maybe the book controller and also author controller. So I can use any of that. Now that also requires another mechanism called the service pattern, right? So now if you are accessing it through the same route, okay, let me show you the route file. In Laravel, we are using a technique known as a resource route, by the way. Okay, web, right? So I'm using this technique, route resource authors, route resource books. And so it will automatically map all the required method to my control. Okay. So a lot of things are automatic. You don't need to type everything in detail. So now if you want to have it now when you're accessing like this, your output is a web page, right? It goes to the Blade engine and then it will render it and give you as a web page, right? That's what you see here. So this is the output. But when it comes to API, you don't want HTML. You need JSON file. You need data only. You can either have a SOAP XML or a JSON data file. Okay, so now for that, if you look at the logic is the same, whether you are getting an API request or a web page request. Only the output is different. So what I will do is I'm going to write a service where it will do the logic inside the service, not in the controller, and then use the controller just to give the output either to a web page or to a API request call. Right, so that we will do later. So today we looked at a theory of patterns. We also looked at how those patterns are implemented using Laravel, things like MVC, things like the factory pattern, the database seeders, migration pattern, stuff like that. These are all patterns, by the way, reusable patterns. Okay, so next time we'll look at a few more patterns. Any questions?